Okay, so let's go with the droplet setup. This is the what? The static amphora. All right. Because I don't want to see this layer over all the static amphora, and actually I could make it over the simulated one, but I don't think it's really necessary because of the motion blur and it's in motion. So I think the most important are the more visible. And for example, this one, or this one, and this one. Those are not really necessary. So yeah, that's why I'm going to blast it, just to optimize it, and continue with that. Here I want to emit directly from the surface. I want to be completely on the surface of the geometry, and this is why I'm using here an inside geo, just to keep the what I am interested, and use a scatter with quite a lot of points. I mean, it's okay. And I'm going to select the point that I want to emit directly from the distance with the main simulation points. So that's why here I have, let's go back, my simulation points. I don't want what is very slow. That's why here I don't have anything more. Let's check. Yeah, it should be the case. So okay, it is just the very slow particles. Then I compute same thing, the distance attribute with the XYZ function. Then blast with blast from the distance attribute. And it is not correct. Yeah, that is better. So this is close to my static amphora. All right. Okay. So this is basically where I want to emit my droplets, and that's why I'm setting here a color, a white color, and here a black color, because I'm going to transfer by distance the color of the points. So I could go higher, for example, let's say 0.5. Now you can see, but let's go back to the value that I liked, and then isolate my droplets, and this will be my emitter, almost, because I don't want to emit from those parts. It's not necessary, it's not visible. So let's kill it like this, just by using, you know, the Y position. All right, same thing. I don't want to emit with a very low density, so same than before, computing the density attribute from the PC num found and the max point number that I found, not that I found, that I've set here, 20, and blast just the very low density value. Yeah, those one. Okay, good. Now I can emit from that. So let's dive inside my amphora. And this one is a bit different. Actually, you know what I've done for this layer? I was just checking how to do it, and I was looking for here the particle fluid pan, and there was this condensation effect that I was checking, and I thought it was good enough to do what I want. So I've just checked inside the new Houdini and copy paste what was done, and what was done was just a pop solver with the source and a pop fluid here, and here the addition force. This is actually the main thing that this tool is doing. But first of all, let's check the pop object. Let's see the pop solver as well, no substeps, so nothing special. Here, the pop source, we are just adding all the points from the first context geometry. Here I'm setting a life of 0.1, because I'm going to pop replicate the driving particle, let's say, with this node. And this particle is going to create a kind of trail with this way, but not for that long, just for that amount of time. Alright, just setting a different friction attribute. So here is my trail. And I don't want to inherit the velocity, because I want to make it static. I mean at the beginning, and then it's falling. We can check the amounts and the shape as well that I created. Using the velocity scale to avoid the kind of, steppy simulation. Then compute an H-frame, because we never know. And here, I think this is the same. No, it's not the same. I had to tweak a bit the parameter here to get the what I want. And I'm using as well the stream source thread, which means the one that the pop replicate is creating actually. So I don't want to use the pop thread over my first particles, because otherwise I will get a different reaction. So this is important. And we need to set as well the collider, which is there. So if you check, I created a special collider for this layer. Let's see that. Basically this is just, let's go. So this geometry, so the one that I'm looking for. And then just a collision source with my volume, the collider and the geometry. There is no velocity, so that's okay. And the voxel size is a bit lower, I think, to get something more detailed and more accurate. Alright, let's go back to the simulation. Okay, and adding as well the ground plane to make sure that it's colliding with the ground. Here is a default gravity, I guess. Oh no, I've decreased a bit the gravity to get a result more consistent, I think, for what I wanted to get. And let's check the adhesion force. So basically, as I said, I just copy-pasted this node from what this tool is doing. And here you have to select the VDB that you want to use. And let's check the code, what the code is doing. So basically, we're getting the volume from this input. Then we are computing the volume sample value with a fit from a max distance from 0 to 1. So if you remember, at the surface the value is 0, and then if you go inside it's minus something, and then if you go outside it's plus something. Then we are saying if rdist, so this one, is less than 1, it means it's close to the collider. Then I compute the normal that I get from the volume gradient of my input, so the vol name, and then I compute a force from this normal that I multiply to a parameter that I have created there. So it was already there, I think. Then I multiply it with the ramp, the stretch by distance, so this ramp actually. It's a kind of fall off when it's far or too much inside of the geometry. This is not really useful, but this one is a bit more. And then I multiply this value by the normal. So the normal is going to push outside of the geometry, but here we have a minus. So it means it's going to attract to the geometry. So to make it more accurate, this code is going to attract the particles when it's close to the geometry. And just after, I'm randomizing the velocity. So when it's close to the geometry, to the surface, sorry, of the SDF volume, because I want to make some particles more stuck on the collider. And that's it. Not a big deal. I'm actually not really sure why it's on the pre-solve instead of the pop solve, but this is what this tool is doing, so I was not questioning, and I'm fine with that. So I think that's it for this layer. Let's continue. Just import it with a dop import, same thing to optimize. So let's delete just all the attributes that I don't need. I don't need to check my driving particles. I could put it both. So if you remember, and I go inside, we have two streams. So the source first input, this is the stream with $OS, and the pop here, the source read with the stream $OS as well. I don't want to get those particles because the time, or not the time, but the age is a bit different. And since I'm going to retime it with the sim frame, I've noticed there was a conflict. So since it's just one particle for a trail, we don't need it at all. So that's why I've deleted it there and update the velocity with the central difference by ID. Don't forget that. And then cache it. And this is the result. Yeah. Let's see what we get here. So it was the flip. Oh no, I don't need this one actually, but this one. So it was this one. Good. And yeah, same thing. So it's very popping. It's really popping, and we don't want that. And this is why after the operation we get this version. And yeah, now it's real time. Good. Maybe there is a bit too much on the side here, but I think it's okay. So same thing, this is a clamp to both for from the original frame range, then the p-scale, then the sim frame attribute, then the retime, same thing. For all the retime that I've done there, it's always the same parameters. So with the cubic, scale velocities, and everything. Same thing, I clamp the position on the y-axis. I modify the p-scale with the fractional part of the sim frame attribute, and then do the VDB from particle, the VDB reshape. Here I've added a smooth because I've checked. Let's see what we have. Like this. Let's set it black, maybe a bit bigger. Alright, let's see with the convert VDB. Yeah, so this is with the VDB smooth, and this is without. I'm losing a bit of detail actually, but the feeling is a bit better, a bit more polished. So I'm okay, I'm good with that. Yeah, it's good to me. Alright. So just after that, we are just combining everything with SDF union. So if you remember, this is our main layer with the flip solver, just there. And then we are combining all the output node that I've created there, and so on. So let's set this back, this back, this back, this back, this back. Then I convert into polygon everything, but it's not finished because this mesh doesn't have any velocity, and it's not going to work with the motion blur. So I have to transfer the velocity, and I transfer it directly from the particles before the meshing operations. So for example, for this one, it's I'm pointing this null. Same thing for this one, same thing for this layer, it's this null, and so on. After, I'm just adding a normal node to recompute it, and we are done. So I'm importing inside the render liquid my setup flip out flip. I could cache everything. I mean, I should cache everything there. But since I was using the render cloud, I didn't want to deal with a lot of data, so that's why. But in production, we should do that. So that's it. Inside the render amphora, I have the static amphora and the simulated one. The ground is there, so this is just a grid with a UV project. So nothing special. My camera is very basic. I just set the translation and rotation, and there I've animated the translation to get the traveling. Another thing inside the material. So for example, this is the ground. I've set all the texture. There is nothing very particular there, nothing specific. The only thing is if you dive inside for the color, there, the base color, I'm using a texture just there. I'm just color correct the texture that I've done, that I've created in Substance. I'm changing the gamma here to 0.5 to 0.5, and I'm doing the same thing for the others, for the color, only the color. Yeah, and this is the liquid, just principal shader as well. So yeah, nothing complicated. And let's check inside the out render. The only thing that I've created here is the extra image plane, the depth channel, and some layer for the comp, which is the diffuse, the reflect, and the refract that I wanted. I've as well enabled the allow motion blur, reduce a bit the limit. That's why it's a bit flickering actually. Put that to 32 and decrease a bit the max ray sample to optimize it, and that's it, I think. Yeah, just here my render, and yeah, I think we are done. So let's see with everything what we have. So let's go there. So this is with all the different layers. And this is in white and black, just to be able to see a bit more the details. And this is the final render and comp version. Yeah. Alright, so I hope you liked it, and I know it's not a real tutorial, and maybe you were expecting a bit more, but I think you have all the information, or almost, to be able to reproduce it. The goal of this, let's say, project is to give you all the setups if you need to recreate it, because you know, when you are in production, you have to be quick and fast, and then sometimes you don't have even to you don't have the time to even understand it, even understand the setup, but just let's say the main key of the process. So I think it might be really useful. I hope it will be. And feel free to share your comments or to give me some feedbacks. I would be more than happy to check that. So thanks for watching, and see you later. Bye bye.